Okay, we're back to a different type of lesson. So today we're just going to investigate graphs of polynomial functions. And just like the videos you've been watching lately, this first slide is just a lot of words, but I need to just lay some groundwork and start things out. So, as you see here, we will use properties of end behavior to analyze, describe, and graph polynomial functions. We will identify and use maxima and minima of polynomial functions to solve problems. So, polynomial functions are classified by their degree. Okay, we've seen these before. The graphs of polynomial functions are classified by the degree of the polynomial. Each graph, based on the degree, has a distinctive shape and characteristics. Degree 1, linear, it's a line. Degree 2, quadratic, it's a parabola. Degree 3, it goes up and down like that. In degree 4, we get a few little blips. In degree 5, let's move. End behavior, it's an important vocabulary word, is a description of the values of the function as x approaches infinity. So if we had our graph as x approaches positive infinity, or as x approaches negative infinity. Okay, look at that again. End behavior is a description of the values of the function as x approaches positive infinity and x approaches negative infinity. The degree and leading coefficient of a polynomial function determines its end behavior. It is helpful when you are graphing a polynomial function to know about the end behavior of the function. So let's look at this chart. First we have leading coefficient a is greater than 0. That means your leading coefficient is positive. If we look at your positive leading coefficient and odd degree, this is where x goes to positive infinity, where x goes to negative infinity. So as x goes to positive infinity, your function goes to positive infinity. As x goes to negative infinity, your function goes to negative infinity. For a positive leading coefficient and an even degree, like 2, 4, 6, as x goes to positive infinity, your function goes to positive infinity. As x goes to negative infinity, your function goes to positive infinity. Alright, leading coefficient is negative, less than 0. As x goes positive infinity, your function goes negative infinity. As x goes negative, your function goes positive. Do you see how those have just switched? Leading coefficient of negative, even degree. As your x goes positive infinity, your function goes negative. As x goes negative infinity, your function goes negative. So here we see there are three things we're looking at. 1, the degree and the leading coefficient of a polynomial function. You're going to be given a function, you just need to write down the degree and the leading coefficient. 2, end behavior, a description of the values of the function as x approaches positive infinity or negative infinity, determining its end behavior. It is helpful when you are graphing a polynomial to know about the end behavior of the function. Example 1, identify the leading coefficient, degree, and end behavior. Leading coefficient, this is already in standard form, so your leading coefficient is -1. Your degree is 4. So that is negative and even. You're going to take that and look at the chart on the previous slide. So if your leading coefficient is negative and you have an even degree, as x goes to positive infinity, your function, or q of x in this case, goes to negative infinity. As x goes to negative infinity, your function goes to negative infinity. Let's look at the next one. Our leading coefficient is 2, which is positive, and degree is 5, which is odd. Look at that chart, and it says as x goes to positive infinity, your function is going to positive infinity. As x goes to negative infinity, your function is going to negative infinity. Okay, old school. You try. Push pause. There you go. Okay, different way we can look at these problems is by identifying whether the function graphed has an odd or even degree and a positive or a negative leading coefficient. So what we do is we look at these graphs. As x is going to positive infinity, what is your function doing? So as x goes to positive infinity, it looks like my function is going to negative infinity. Okay, as x is going positive, my function is going negative. As x is going to negative infinity, my function is going to positive infinity. Check out that chart and pick the right positive or negative leading coefficient, odd or even degree. P of x is an odd degree with a negative leading coefficient. Okay, next one. As x goes positive, your function is going positive. As x goes negative, your function is going positive. That just means your function is even degree with a positive leading coefficient. Last slide, you try these two. There you go. That's the first half of the lesson for today.